In this problem, we're going to use DeMoivre's theorem to find the two square roots of negative 9i. This is really cool stuff. I love this stuff. It really helps you to see that the number system is not really what you thought. It's a little bigger and more complex. Get it? Complex. Remember, the reason for this channel is to help you pass your math class so you can reach your goals and get a better life. Using DeMoivre's theorem to find two square roots of a complex number. Coming right up. DeMoivre's theorem states that if we have a complex number written in its trigonometric format and it's non-zero, and n is some positive integer, then our complex number z has exactly n different nth roots given by the formula that you see there. Now we're going to apply this formula and we're going to find two square roots of minus 9i. DeMoivre is most famous for this theorem, which links complex numbers with trigonometry, and that was never done before. He lived in very tumultuous times. He was born in the Champagne region of France in 1667 and lived 87 years. When he was an adult, he was a Protestant, so he was educated in Protestant schools. Louis XIV, the King of France, issued something called the Edict Fontainebleau, which forbade Protestant worship and required all babies be baptized as Catholic. So DeMoivre moved to England, where he befriended Halley of Halley's Comet fame and Isaac Newton, who invented calculus. So he certainly had an interesting life. So our first task is to write minus 9i as in its trigonometric format. So the first thing I want to do, let's find r. That's the absolute value of minus 9i. And that, of course, is just going to be the square root of minus 9 squared using my formula, and that's simply 9. So I found that r is equal to 9. In order to find theta, which is my next task, I want to draw a picture. So if this is the real axis here, which corresponds to the x-axis, and this is the imaginary axis here corresponding to the y-axis, minus 9i is about here. We always measure an angle starting from the positive x-axis and going on around. Not the most beautiful circle, but this is theta here, and this actually ends on one of the quadrant barriers here, so that is minus 3 pi over 2. So minus 9i is equal to r, which is 9, times the cosine of 3 pi over 2. That's just going to be 0, isn't it? Plus I times the sine of 3 pi over 2. And sine of 3 pi over 2 is just going to be negative, so that's going to give me negative 9i. So that is in fact correct. And only now that I have this written in trigonometric form, I can apply the theorem. And I'll notice for my problem, I want n is equal to 2. I want to get two roots. And I've got r now, I've got n and theta, so I have everything I need to apply the formula. So let's apply DeMoivre's theorem. WK, in our case, is equal to the square root of 9 times cosine. And now we have theta, which is 3 pi over 2, plus 2 pi k all over 2, plus I times sine with the same argument. 3 pi over 2 plus 2 pi k all over 2. Now that's ugly. I really want to rewrite that and make that easier to calculate. So that's going to give me then WK, and that equals 3 cosine 3 pi divided by 2, all divided by 2. That's going to give me 3 pi over 4 plus pi k. So it's a little easier for me to calculate. Times I sine, same thing, 3 pi over 4 plus pi k. And there's my value. Now I have to find this when k equals 0 and k equals 1. That is 2 roots. Considering our first case, we'll find our first root. So w sub 0, w naught, so that's sometimes called, that equals 3, times the cosine when k equals 0. I'm just going to get the cosine of 3 pi over 4. I might notice there that 3 pi over 4 is going to be in quadrant 2, and my reference angle is pi over 4. So that's going to give me 3 times the negative value here, square root of 2, all divided by 2, and I'm going to get a positive value here, square root of 2 all over 2 times I. And that actually tells me that w naught is equal to negative 3 times the square root of 2 all over 2 plus 3 times the square root of 2 all over 2i. So that's my first square root. My second square root, I'm going to have to find where k is equal to 1. So w1, and that's 3 times the cosine of 3/4 plus 1. So that's going to give me 5/4 pi plus I cosine 5/4 pi, and I know that 5/4 pi is actually going to be in quadrant 3. So that's going to give me 3 times negative the square root of 2 over 2, that's the value for cosine 5 pi over 4, and minus the square root of 2 over 2, that's the value for sine 5 pi over 4 times I. And that tells me then that w sub 1 is equal to negative 3 times the square root of 2 over 2 minus 3 times the square root of 2 all over 2i. I have two different square roots here, and we're going to use the calculator and check our values. So if I had found 2 roots of 4, so suppose I said the square root of 4 is equal to 2 and negative 2, you would know that I could take both of those roots, square them, and get 4 back. So that means that 2 squared equals 4, and also it means that negative 2, now I've got to square the whole thing, that also equals 4. So we're going to do a similar check using our calculator. I'm going to use parentheses. Now I need negative 3 second square root 2. I'm going to press this button so I'm out of the square root sign divided by 2, so that's the real part, plus 3 second square root 2. I'm going to press that to get out, and divided by 2. Now I want to multiply by I, so that's second, and I is right here. And I'm going to close those parentheses, and then I'm going to square this. And when I hit enter, expect to get minus 9i, and I have in fact done that. So you can check once you've found your roots on your calculator. I want you to check minus 3 square root 2 over 2 minus 3 square root 2 over 2i. Square that and see if you get negative 9i. Hey, thanks for listening. I would like to invite you to like this video and subscribe to this channel. Thanks very much for listening.